Can we have a flow stream in vacuum? Can we make a helix rotate inside a vacuum chamber? Welcome to Tekle Lyophilization Knowledge Hub. In this third video, we are going to be talking about high speeds in vacuum. Vacuum technologies are not very common in the industry. Most engineers and technicians, they know about pneumatic transportation in vacuum at 800 millibars, where 200 millibars below the atmospheric pressure is enough to move heavy objects. Some other technicians and scientists, they may know about other vacuum applications, like vacuum drying, where water is evaporated at cold temperatures, like we showed in our first video, where pressures are in the range of 30 millibar. But there are not very much people that knows about the pressure range of freeze drying that occurs in between 500 microbars and 50 microbars. So density depends on pressure. The lower the pressure, the more volume a gas occupies. And consequently, the lower the pressure, the higher the speed of a gas in a flow rate. But can we have flow streams in vacuum? Can we make a helix rotate? Let's see the following video. We are making use of our freeze dryer and a really light helix that is rotating with barely friction. We are first doing a freezing step, freezing water, and then going to a primary drying step at 0.05 millibar. And then we see that the helix is rotating. But the helix rotating means that we have a flow stream inside the vacuum chamber. I'm going to give you some seconds now so you can think about the answer. There is not a clear answer to this question. And this is because at the freeze drying pressure range, gases are starting to behave differently. The molecules are not colliding between them anymore. Let's go to the whiteboard for a better explanation. Here we can see two areas drawn in blue, A and B, with two different pressures, 1000 millibar atmospheric pressure and 0.001 millibar deep vacuum below the pressure range of freeze drying. Here we can see a green rectangle representing the walls of a room. So the molecules at the center at atmospheric pressure are mainly colliding between them, and only the molecules close by the wall are colliding with the wall and with molecules. This behavior is different in deep vacuum. Because of the low density of the molecules, all of the molecules are colliding with the walls. Let's imagine that we are installing two doors in opposite locations of the room, and then we are opening one of them. What is going to happen is that this door is going to hit the molecules nearby, and at the same time these molecules are going to transfer the movement very fast, instantly, to the opposite direction, making the other door being open. This is the normal behavior that we have at atmospheric pressure. When we are entering in a room and a window is open, we can notice that it's instantly closed. But if we are doing the same in deep vacuum, when we are opening the door, of course, some molecules are going to be hidden by the door. But these molecules are going to not be able to transfer the movement to the other part of the room, and the other door will not notice it. This is why gases are behaving differently in atmospheric pressure and deep vacuum. And in freeze drying, we are in between the two behaviors, in between the two ranges. So, answering the question, if a flow stream is making the helix rotate, we need to say that it's not 100% true, because the flow regime that we have in freeze drying is in between molecular flow from deep vacuum and laminar flow from atmospheric pressure. Freeze drying occurs at low pressures and low densities with high velocities, what makes necessary a specific design of all the technologies involved in the process. The sublimating vapors at high speeds can drag out particles, and it is necessary to include a protective membrane to avoid the flyout, like in our bag with filler assembly. The membrane needs to be a barrier to particles and contaminants, also to water in liquid state, but should allow the vapors going out without minimum pressure gradient. If you want to learn more about freeze drying and about how Teclen can help you with it, please do not miss the following video of the Teclen Lyophilization Knowledge Hub.